I'm Dr. T and welcome to my office. So today I'd like to talk a bit about mixtures. So when we think about mixtures, as chemists we usually think of kind of three categories of mixtures. There are more, this is not exhaustive list. But for us, there's kind of, nice three boxes it's nice to put things into. Now, once again, nature does not have these boxes. Nature is not behooved to us to conform to these boxes. Therefore, nature does what nature does. But it's useful to put things into a conceptual framework. So the first of the boxes, and the one that as chemists we typically like to deal with the most, is that of the solution. The solution is going to be a homogeneous mixture. It's going to involve relatively small particles. If you were to pass them through a filter, they would simply go through. If you were to pass them through a semipermeable membrane, they would simply go through. If you were to let them sit, they would just sit there. They wouldn't separate or do anything fancy. They behave very much like one thing. And this is your solution, made up of very small particles. Typically when we talk about solutions, we're going to talk about them as being of two components. Obviously you have to have two components if it's a mixture. The component that is in the majority is called the solvent. Typically this would be one substance, but there are scenarios where we refer to a blend of substances as the solvent because, language and, trying to describe nature better. But the thing in kind of the majority is going to be the solvent. It's essentially what's creating the party for the solution. And then the things in the minority are going to be the solutes. Now, when we think of solutions, we typically think of solutions as liquids. Quite often aqueous solutions, which are ones that are derived from water, or water is the solvent. So things such as seawater. A couple of quick points though. One, water does not need to be the solvent, nor even involved at all. So if you imagine gasoline, that is a solution of a lot of different hydrocarbons, and unless that gasoline's not particularly good quality, there shouldn't be any water in there. But solutions don't even have to be liquids. If you look at air, that fits very nicely into the definition of a solution. So solutions could be solids, liquids, or gases. It's basically going to be any truly homogeneous mixture is going to be fitting within the solutions box. That said, we typically are thinking of solutions as liquids. That's typically where we want to focus in on the most, just kind of because for practical reasons. Now, on the other end, so instead of having very small particles, you have very large particles. This would be a suspension. So presumably the medium that the material is suspended in is going to be, a fairly small particle, but the material that is the suspension is going to be reasonably large particles. So the classic would be something like silty water. But this could also be things like smoke as a suspension. Now, with suspensions, if you pass them through a filter, the particles are large enough they're going to get caught, so you'll separate the suspension apart. If you just let it sit, the particles are large enough that gravity will have a meaningful impact on them and pull them down, and it will separate. If you pass it through a semipermeable membrane, yeah, they're not going through. If they can't go through a filter, they're not going through a semipermeable membrane. Okay, so that is going to be your suspension. Fairly large particles, and they're suspended. They're floating around, but they will settle out. Now, in between the two, kind of in that borderland between heterogeneous and homogeneous, is the colloids. They are technically heterogeneous mixtures. The clear distinction here is that when you look at a colloid, it's going to start scattering light. Solutions don't do that. Solutions might absorb light. They might change the color, which is absorbing some of the light, not all of it. But they don't scatter light. They don't have this milky look. Whereas colloids and suspensions have particles that are large enough to scatter light. And so the medium-sized particles of the colloid are able to scatter light. They're small enough that they don't go through filters, but too large to go through semipermeable membranes. And they're also too small to actually settle out. So if you have colloid and you just let it sit there, it's not going to settle out. Homogenized milk is a classic example of a colloid. It won't separate out. It just kind of sits there in your fridge and eventually goes bad, but that has nothing to do with the being mixture. That has to do with bacteria and whatnot. Unhomogenized milk, however, will still be a suspension, and thus that will separate out. At least in part. It doesn't fully separate. So with that said, have a wonderful day.